This is J.K. Soumya. I'm Assistant Professor in the Department of Civil Engineering, working in Nehru Institute of Technology. So my subject is the soil mechanics. I'm going to take compaction of soil under soil mechanics. Before going to this topic, let's see about the course objective. The course objective is to classify the soil based on index properties and assess their engineering properties based on classification, to know about the fundamental concepts of compaction, flow through the soil, that is permeability, and stress transformation, stress distribution, consolidation and shear strength of the soils, to know the design of both finite and infinite slopes. So this is the course objective. And coming to the topic compaction of soil, we must know what is compaction. So what is compaction? It is nothing but the expulsion of air from the soil. Expulsion of air from the soil in the sense we have to rearrange the soil particles into closest state by mechanical means or hand operated. So that is a compaction. So this compaction is mainly needed for improving the soil characteristics. So the main principle behind the compaction is it reduces the porosity of the soil and it increases the dry density of the soil. And how it is achieved? This is achieved by rolling, tamping and vibration methods. So these are the methods. We will discuss these methods in the following slides. And there is a degree of compaction. There may be the high degree of compaction and the low degree of compaction. So these degree of compaction are characterized by these three factors, that is the moisture content, amount of compactive effort and the nature of the soil. That is the moisture content. If the moisture content increases, the degree of compaction varies. And also the amount of compactive effect, that is the amount of compactive effect is nothing but the compaction we are giving to the soil for improving the soil characteristics. So that also differs with the degree of compaction. And the nature of the soil, whether it may be the cohesive soil or the cohesionless soil, these also characterize the degree of compaction of the soil. And this is the compaction of soil. So what is the difference between the compacted soil and the loose soil? So this is the loose soil and the compacted soil. After compaction, the air volume gets decreases, that is the air is expelled from the soil. So that is the compaction. Okay, so after the air is expelled from the soil characteristics get improved. And the next one is the effects of compaction. So what are the effects of compaction? It increases the dry density and it increases the shear strength and bearing capacity. It reduces the settlement. This is the main effect of the compaction. And it decreases the permeability and compressibility of the soil. So these are very important for the soil because based on these characteristics only the building can be built upon the soil structure. And why we need this compaction? So from the picture we can say that without compaction, what happens to the building? So soil stability is very much important. And the next one, it improves the soil bearing capacity. In the first figure we can see without compaction the load structure can be only minimum. But after compaction the superstructure can have a more weight. And the next one, it decreases the settlement. So we have different types of settlement, differential settlement, total settlement and isolated settlement and everything. So after compaction the settlement can be minimized, and the increase in soil stability after compaction, the soil stability will be getting increased, and decrease in water seepage, that is the permeability. Permeability of the soil is getting decreased after compaction. When the permeability of the soil is decreased, ultimately we can reach the higher bearing capacity. And where compaction is required? Mainly it is required in the construction of earth dams, canal embankments, highways, runways. That is prior to this construction the soil has to be prepared, that is the compaction has to be completely done. And how is this achieved primarily? That is three methods like tampers, rollers and vibrators. So these are the equipments which we use to compact the soil primarily, but we have other methods also. This is the primary methods. So what is tampers? So we have two types of tampers, hand operated tampers and mechanical rammers. So hand operated tampers, this is a hand operated which weighs about 3 to 5 kg mass, that is using manually operated it is done, that is the compaction of the soil is completed. And mechanical rammer using gasoline power or some pressure which is induced in the instrument, the compaction is done in the soil. So next, tampers, it is used to compact soils adjacent to existing structures. It is used to compact soil in between the trenches and behind the bridge abutments. Can be used for all types of soil, whether it may be a cohesive or cohesionless, we can use these tampers for all types of soil. And next one is the rollers. We have three types of rollers, smooth wheel rollers, pneumatic tire rollers and sheep foot rollers. So this is a smooth wheel rollers. It consists of a large steel drum at the front and one or two drums at the rear end. Okay, so tandem roller and three-wheel roller are the two types under this smooth wheel. And tandem, it consists of one wheel at the front and one wheel at the rear. It varies, the weight varies from 2 to 8 tons. And three-wheel, one wheel at the front and 2 or 3 wheels at the rear. That the weight varies from 8 to 10 tons. That is for the large capacity we can use this three-wheel rollers. So smooth wheel rollers can be used to compact soil, whether it may be a well-graded sand, gravel, crushed rock, asphalt, where crushing is required, used for finishing the upper surface. So this cannot be done for the deep compaction, only the upper surface compaction can be completed. 100% ground coverage can be done under this wheelbase. The contact pressure between the soil is 380 kilopascal, can be used for all types of soil except rocky soil, that is hard stratum cannot be done using these smooth wheel rollers. Optimum working speed is about 3 to 6 km per hour. And pneumatic tire rollers, it is a heavily loaded wagon with several rows of 4 to 6 closely spaced tires. So it consists of several wheels in the front and the back. It is used for compaction of subgrades, bases, bituminous mixers, layers of loose soil and closely grained sands. So suitable for both cohesive and cohesionless. Whether it may be a clay soil or the sandy soil, we can use this pneumatic tire. The coverage area is about 80%. Gross weight is about 6 to 10 tons. Optimum speed is 60 to 24 km per hour. And next one is the sheep foot rollers. It consists of steel drum. May be round rectangular or the lugs. That is in the steel drum we can see the impression of the sheep foot. So that is the name, sheep foot rollers. It is used for compacting fine grained such as heavily clays and silty clays. So mainly it is used for the cohesive soil. Compaction of soils in dams, embankments, subgrade layers in pavements and railroad construction projects, we can use the sheep foot rollers. So it is the coverage area is about 8 to 12% and normally the speed is 6 to 10 km per hour. The pressure on the feet may be increased by filling the drum with wet sand or some other material. So the course outcome is it classifies the soil and assess the engineering properties based on index properties. We can understand the stress concept in the soil. We can understand and identify the settlement in the soil. We can determine the shear strength of the soil. So analyze both finite and infinite slopes. These are the course outcomes. So these are the important questions which can be asked from this compactions of soil. So these are my references. Thank you.